Hello everyone. First of all, I would like to welcome you all for the webinar on NoSQL databases, Cassandra and MongoDB, two of the most widely used NoSQL databases currently. So my name is Saran Kumar. So I have close to 7 years of experience working on databases, so both relational, non-relational databases and distributed systems, architecture, etc. So I'll be demonstrating, I'm going to talk about these databases and also demonstrate you some of the related topics. Okay, I'm going to show you how to perform some installation, do some basic operations with one of the NoSQL databases that I'm going to present today. All right. So during the session, I could see that, first of all, I could see that there are too many participants that have joined today's session. I'm very glad and happy to see so many participants. So since this is going to be an 1 hour session, so there, I know that, there will be a lot of questions from a lot of participants. So after every topic that we're going to talk about, there will be a small break during which I would like to, answer the questions. I would like to take the questions from you all. All right. So, and again, by the end of the presentation, we will also have another question answer session. Okay. I will be. I have the question box in front of me. So whenever you have a query, feel free to post your questions. Okay. And after a few slides or after a very specific topic, I'm going to answer these questions. All right. So let's get started. All right, so the objectives of today's session are, first of all, we'll just quickly go through the NoSQL databases, all right, the different types of NoSQL databases that we have, and then what are all the fundamental concepts behind this databases, like the CAP theorem, the asset or the base properties, all right, which these databases support, and then we'll quickly see like what are all the different options that must be considered when opting for a specific type of NoSQL database. All right. So what are all the different constraints? What are all the advantages or the disadvantages that must be considered when you want to go for a specific NoSQL database? And then we will quickly go through some information about data modeling. We have two different NoSQL flavors today, Cassandra and MongoDB. So we'll have data modeling concepts, an introduction of the data modeling concepts, and then some of the real world use cases of both these technologies, who are all the companies who are making use of these technologies, what are their use cases, how they are making use of these technologies, how they are scaling up, all right, etc. Those are some of the things that we'll see. And after this, finally, I'm going to show you how to perform some operations on these technologies. Like I'm going to show some operations on how to perform installation of MongoDB on a Linux system. How do you connect? How do you set up the server and the client? A very basic example. How to create tables, how to query the data, some of the operations, basic operations that are performed, all right, so that you can have some feel of how the technology works, all right. So these are the objectives for today's session. So moving on, so the first topic for today is understanding NoSQL databases, all right. So this NoSQL movement has started somewhere in 1990s. Prior to that, we had as you can see on the screen, we had relational databases, OLTP based, and also the other model that you can see is OLAP. All right. So you must be pretty much aware of the list of databases which are shown here: Oracle, MySQL, MS SQL, Microsoft SQL, and DB2. All these databases. These are like databases that are in the market for a long time, right? So there are a set of rules that must be so that every application developer has to remember when making use of these tools or these databases. All right. So mainly The application developer, when he starts developing something, right, so he knows that there is a database out there. This is what this particular database supports. So according to that, I have to develop my application and then integrate that to the database. All right. So that is how the thinking was previously. But gradually, the kind of applications that are being developed, you might have seen that there are a lot of social networking apps or applications that are coming up. The pace of development has changed drastically. The development cycles have shortened, and also the kind of data that is getting generated. So far, all these RDBMSs, they only support relational data, tabular data that is stored in rows and columns. All right, but with in the last decade, the number of social networking sites have drastically increased, resulting in generation of different types of data: structured, semi-structured, unstructured data. And since there is a need in order to generate in order to develop such applications, at the same time, the kind of output that the kind of data that they generate, so there is a need to have a different kind of databases that can support all these kinds of data formats, right? So obviously they would have tried the relational databases along with these applications, but they haven't seen any good performance or kind of scalability that they were expecting. So they felt the need for a different kind of database that would suit the modern requirements, all right, modern applications. So that's when the movement of NoSQL databases have started, all right. So till that moment, we had only the relational databases, the tabular format, so structured data, and the data from multiple relational databases will flow gradually to a data warehouse on top of which we run some analytics. All right, so this is what is the native databases that we have been using so far. So once they felt the need, so a lot of NoSQL flavors have started coming up. A lot of people have realized the potential of NoSQL databases. So that's the reason we have a lot of different types of NoSQL databases available in the market. So what are all the reasons behind this? If you look at the kind of data that is getting generated, it's huge, tremendous, right? Huge volumes of data are being generated from Twitter or from Facebook every day, all right, from all these messages and all. And then the pace at which this data is generated is also huge. So these are all different parameters that you can see on my screen. Okay, so I mean, with respect to all these parameters, you can see that there is a huge change. All right, so even it's not just the normal format or text format of data, but even people, they send messages, they share the messages, they share videos. All right, so data of all sorts of types, that is being moving around all these applications and all, and it is generating huge volumes and varieties. All right, so like that you can see there are even other parameters, the type, the value of the data, the type of data that is getting generated and the value that it holds, and then the volatility, so it keeps changing continuously. All right, and it is and there is also this parameter called as veracity and variability. So with respect to all these parameters, all right, so they can see a lot of changes with respect to the data that is getting generated, and people were really eager to see a database, all right, that supports all that comes as an add-on to all these features. So they have, though even after testing all these scenarios on RDBMS, they have realized that that this is not the right fit. Okay, so basically RDBMS cannot satisfy all these aspects. Okay, so that is where we have come up with NoSQL databases. Honestly, a NoSQL database can never be a replacement for an RDBMS, but you need to understand that the applications are different, the fields are different, the use cases are different. All right. So previously we had only one solution, RDBMS, for all the use cases. But now that with the NoSQL space that we have, NoSQL databases that we have, we are slowly, dividing that space. All right. So we are trying to identify that, okay, so these are all the applications or the use cases which would be a right fit for NoSQL. All right. So NoSQL would be a right fit for those applications. The applications would scale better, would perform better with NoSQL. So gradually, that's how the NoSQL database movement has started. We have a lot of databases, a lot of development is happening with respect to the NoSQL databases. So basically, there are some good set of features that are there. So I'll just walk you through that slide as well. So NoSQL basically it refers to not only SQL. Okay, so it's an acronym that is used in the initial phase to say that it's not just the SQL databases that are present in the market, but we have come up with something which is something other than, which is something beyond the SQL which is available currently. All right. So we have different flavors of NoSQL databases. Some which support SQL. There are some which have their own format, query language format. All right. There are different types, but this is a generic acronym that is used to represent all the NoSQL databases. All right. So basically, even by the end of the day, it's database where the data will be stored. But the basic there are some important difference, like how the data is being stored. So what is the data model? How is the retrieval happening? Okay, and how does these databases scale? All right. So what would be the performance of these databases? Will there be any schemas as a part of these databases? How is it going to be? These are all the different types of questions that people usually have. So we'll just go through one after the another. All right, in having a better understanding, we'll have a better understanding of what these are, what these parameters are. So bigger data handling capacity. The first point. Why NoSQL? Because we can get a bigger data handling capacity. So the first point what I would like to mention before moving on to this data handling capability, right? So previously, first of all, the first important thing that we have to remember is the scalability part. All right. So previously, for example, you have started an application. All right, and you have taken, for example, an instance which is have 1000 gigs. All right, and 100 GB RAM, some random numbers that I've taken. All right, and you have started that application. For example, consider it as a gaming application. So people have started playing that game, and suddenly within a week or a month's time, okay, the load has increased 10 or 20 times. All right, and you felt the need for having a higher capacity because the current capacity may not support. What if the load still keeps increasing? All right, so that is where either if you are using an RDBMS in such a scenario. So what you have to do, the only option is every hardware will have certain limitations. You try increasing the RAM or you try increasing the disk, and that too you can do only to a certain extent. All right. So like those are the hardware limitations. If you reach that, you have to replace that with a better, higher range of hardware. All right. So like that, people ended up spending a lot of money in getting all the IBM machines. All right. So the first thing is there people have identified that you need to have a downtime with your application. Whenever if your application goes beyond its capacity, again we need to invest a lot of money, and again the scalability is becoming a problem. The scalability, the linear scalability, if you can keep increasing the existing hardware only up to a certain instant, and this is gonna take a lot of a lot of efforts must be put. It's going to take a lot of time, and a lot of other things are involved, right? But imagine a scenario, okay? So suddenly the load has increased, okay? and within few minutes I have doubled my infrastructure, or I have made it thrice or 4 times. All right. So as the load keeps on increasing, if I have the capability to increase my infrastructure without any downtime, without any performance impact, so like horizontal scalability, you are adding, n number of instances parallelly which are capable of handling all the load that is coming to your instances. So imagine, so that is the kind of model that has come up. At the same time, instead of spending billions of dollars on the high-end machines, the people have started coming up with technologies which can scale on commodity hardware, which are cheap hardware. You can bring 100 normal, cheap instances, combine all the instances and start your application. If an instance fails, just replace it with another instance because they're very cheap. All right. So that's how they have started attaining this high scalability part. They're able to scale it. So this is one area, first important area. So they are able to save money. They're able to get the scalability. So once you have got scalability, the load will be evenly distributed across. So automatically your performance increases. The load on an individual instance gets reduced, right? So like that. So those are the 2 important parameters, first of all, which you have to remember, right? So other than that, every RDBMS, along with RDBMS, in every architecture, you might see a caching layer, right? So which is, so always the data retrieval operations, retrieving the data from the memory is faster than retrieving from the disk, okay? So obviously, every application would have a caching layer, but when it comes to NoSQL databases, they are supporting the caching layer internally. It's an inherent quality, all right? So you need not have to set up a new caching layer in order to speed up the things. That is an inbuilt functionality available, okay? So here itself, we have come up with 3 different important, perspectives. Apart from that, the RDBMS, they only support relational data, right? But the NoSQL databases, they support non-relational data. Any kind of data can be converted and stored inside that database, all right? And then in order to store such a kind of data, the schema part has been removed. So there is no schema. The NoSQL databases are schemaless. So people who would use it to the relational side, they might wonder, like, how does the database look like if there is no schema? So basically here, with respect to, if you take any one of the NoSQL database to explain this concept, the schema would remain at an individual object level or a document level, all right, but not at a table or a database level. So you can insert different types of data. So imagine the ease of storing the data if a database supports like that. So imagine the ease of development. So even the developer's perspective is also very important when we talk about the database. Other than the features that I've explained so far, even the developer should feel easy in order to start developing applications that would support, right? So these NoSQL databases, they even have this functionality. They are, so the developer feels very comfortable, very easy. The time taken in order to develop an application has reduced drastically because of when a NoSQL database has been considered. But by the end of the day, as I mentioned before, they are never a replacement for RDBMS, all right? But they have their own specific use cases, supporting use cases to which they are a good fit. So such kind of applications, if you opt a NoSQL database, then your development time will be faster and you'll get a better performance, all right? And also there are a lot of other features that I'm going to talk about, okay? So if you look at my screen, there is another interesting feature called as replication, okay? Say for example, you are having a single node which is handling all the load, all right? Suddenly if the instance has crashed, then how do you face such a scenario? So we have this concept of replication, where instead of, as I've mentioned before, one expensive instance, you come up with commodity hardwares and you make use of one commodity instance, all right, as your server, and then have some replicas. Replicas are nothing but, the instances that continuously stay in sync with the master. Okay, so whatever the primary, or consider them as primary and a secondary, just for the understanding sake. So your primary will have it acts like a master with all the data, and these secondaries, so they are not available all the time. That means they don't take up any kind of inserts, but what they do is they always try to sync the data from the master. So in case if the master is down, automatically one of the secondary comes up and it starts acting like a master. And the end user, the best thing is the end user will not be able to understand that something like this has happened in the background. So imagine such a feature. What if such a feature lies with respect to a specific database, right? So these are all some of the good advantages, good features of these databases. But on the contrary, we also have some negative options if you compare them to relational databases. But honestly, these are not the negative points, but these are the features that have been removed in order to scale the database, like joins, for example. Okay, so the RDBMS databases, they support joins, but the non-RDBMSs, they do not know. The NoSQL databases, they do not support, they don't have table structure, they don't have joins. That means you will not find these functions like group by and order by, all these things. I mean, mainly related to the joins here, because joins basically, what happens is when you use a join, right? So basically it tries to combine the data from multiple tables. And imagine if a table has 1 million records, it's going to take a lot of time in order to fetch the information, group it, and then display that information to the end user, right? So here what happens is, so we have completely removed the concept of joins. Okay, so in one way it's an advantage for the NoSQL space, and in the other way, so we cannot say that it's a disadvantage, but it is mainly targeted for such kind of applications. So the data modeling will be done keeping in mind that there are joins are not supported by these databases, all right? And then there is no transaction support, all right? So asset properties are not supported, all right? That means, so as I've mentioned before, so that is where, RDBMS has this unique support. RDBMS, they support transactions, whereas NoSQL databases, they do not support the transactions. So it's all about, in order to gain something, we have to lose something. So these are the features that have been lost, and for that they have gained the performance, they've gained the scalability. So if you have such kind of applications where the performance is a major thing, and scalability is a major thing, along with the other factors, all right, then you might want to go for NoSQL database. So that is how they have split the overall application use cases in between relational and non-relational databases. The next one is CAP theorem. All right. So if you have heard about the CAP theorem, theoretically these are three properties: consistency, availability, partition, tolerance. All right. These are the three important features that are expected from distributed databases. All right. But it is impossible to have a system that satisfies all these three features at a time, at a point of time. All right. So it has been so for every distributed system. So at least 2 out of these 3 features. A distributed system must satisfy 2 out of the 3 features that are part of this theorem. Alright, let's go one after the another. The first one is consistency, okay, which means that the data in the database, it remains consistent after the execution of an operation. So imagine, let's take an example of an application. All right, so there are different points. All right, so multiple users can open the application from different points, and they have a common database. All right, so for example, whatever changes that a particular user has done, okay, so this change must be consistent across. So all the users, all right, wherever they are, they should be able to see consistent data. Whatever change that has been made, that must be same across all the access points. All right, so that is what consistency is. The next one is availability. All right, which means there shouldn't be downtime. System must be available all the time. Okay, so you need to come up with such an architecture. So as I've mentioned before, right, with respect to the commodity hardware, so if you're using 100 instances, even if a single instance is down, you have a replica that automatically comes up so that the end user will not be able to see that difference, right? So that is a quick example regarding the availability part. That's how you make the system available all the time. And then partition tolerance. So with respect to partition tolerance, right, so now we are seeing that the databases are distributed geographically. So you may have a cluster with some 10 instances, and those are distributed across the globe. So there is a possibility that there is a network outage, right? Or even if you have 5 instances in a single country and 5 different places, there is a possibility of a network outage. So we need to ensure that even if there is a network outage, all right, so the system is not down, the application is not down, the end user is not going to get affected. All right, so like that, these are the 3 different 3 important things that must be considered when developing and using a NoSQL database. Okay. All right. So I'm just going through the questions. All right. Quickly, I'm going to answer a few questions now. So, so one of the question is, what is velocity? So among all the factors that are being considered with respect to the way data is getting generated, all right. So velocity refers to the pace at which data is getting generated. All right. So just imagine that how many people must be making use of Facebook. You might see that there will be a lot of users, right? Everyone will be sending messages or posting some ad which will be shared across, it will be liked. So every click that you do will generate a lot of data, will generate data, at least click data will get generated. So this data, the pace at which this data is getting generated is huge. So that is what refers to the velocity part. Okay. And another question is about the document level schema, which I have said. So in an RDBMS, all right. So before, for example, you wanted to create a new database, you wanted to create a few tables, right? So before inserting data, before storing the data inside an RDBMS, you have to define the schema that this is what the table is going to look like. These are all. These are all the number of columns. These are all the type of the columns. This is the type of data that will be stored. So the basic definitions which you make with respect to the schema, right? So all these operations, they are completely avoided with NoSQL databases. That means if you want to insert some data, just run a query and insert the data. The table may not be present, the database may not be present, all right, but still without the creation of any kind of schema, you can insert the data inside the database. So imagine, for example, take another example, okay? Say you wanted to create a new table and dump the content from, or you wanted to come up with a new database, you are doing some migration part, okay? So what happens is you need to create the entire schema, entire tabular structure, and then you need to copy the content from one database to the other one. But here it's going to be very simple, okay? Because the schema is not involved, you need not have to explicitly define anything. Imagine that how much of an administrator's work gets reduced here. So by the end of the day, the developer, he's going to decide what kind of table he want to create, all right? He's going to choose the column names and all, and he'll simply start the application which will automatically create the table and dump the information into that table, all right? So that is where NoSQL databases are very beneficial, and they're very fast. They reduce a lot of system admins work. All right, next there is a question, another question about the partition tolerance. How does the systems work when there is a partition tolerance? Okay, so I'm going to explain this concept, or if I say generally, right? I mean, I'll give an example. When we go to Cassandra or MongoDB, there I would explain you about the partition tolerance. We will take a very simple cluster, all right? So even though there is a network outage, these two systems, all right, the two sides of the cluster, your application is not down. So the requests would still be taken by these instances, all right? And I'll give you more details. Let me explain that architecture first, then it will be easy for you to understand this concept with an example, all right? And there is another question. It's from Karthi. So he's asking, I have a small doubt storing the data in the hardware using RDBMS system and distributing the data over hardwares using NoSQL. Can you please explain further? Okay, for now, let me give you an example, okay? So imagine that there is a single server, okay? And I hope you might have heard about the load balancer. So the end users are facing your application. So some hundreds of users are connected to your application, and the load balancer basically, it helps to distribute the load. But here you have a single server which is linearly scalable, and all the load is going on to that single server. It is handling the entire load. Now imagine a different scenario where I'm talking about the distributed database, okay? You have 10 instances, all right? All 10 instances are sharing the load. Now the load balancer, what it does is, whatever, irrespective of the number of requests that are coming, the data is distributed among all the 10 instances. So the load will be split among 10 instances. So parallelly, the 10 instances will be serving the requests, all right? So imagine the load will be equally distributed, the data is equally distributed, and imagine that since the load, obviously the load will be less, the performance will be more, and the additional advantage is, imagine that, okay, all the 10 instances are taking a lot of load. I mean, the end users have increased, all right? So obviously the load has increased. Now what happens is, you wanted to again, increase, you wanted to horizontally scale. You bring 10 more commodity servers, add to the existing 10. Now it became 20, all right? And automatically you auto balance the load. That means whatever data which is there, again redistributed among all the 20 instances, all right? And the load balancer would automatically understand that, okay, now before it were 10 instances, now there are 20 instances. Again, it will start distributing the load across the 20 instances. So if that is the kind of architecture that you have, so imagine how the performance would be and how the scalability would be, all right? So basically, whatever inserts that you are doing, they are not going to a single instance, but they are distributed among 10 or 20 instances. So parallelly, along with the inserts, even the read operations are also distributed, all right? So automatically the load gets reduced, the performance and other factors would be improved. let me know if you have any further question regarding this. All right. So I'm going to explain more with respect to all these features when we go to the corresponding database like Cassandra or MongoDB. Then you may understand better. All right. I'll show you. Maybe I'll quickly draw that architecture and show that you how these things work. All right. All right, just one last question. Maybe don't worry, I'm gonna make a note of all the questions. In case if your question is not answered, we'll make a list and we'll reply back to these questions. All right. So one last question. So from a participant who's Jay. So he's asking like, how does the system decide which instance is to be communicated for which request? That's a good question, Jay. So as I have mentioned, right, there is a load balancer, and which distributes the load across all the instances, right? So this is just a simple example that I have mentioned, but other than the load balancer, so it also there is also another system in place that maintains the metadata of all the instances. For example, imagine that along with the load balancer, there is a functionality as a part of the load balancer itself. Okay, so what happens is whenever the data gets redistributed among all the 10 instances, okay, this information is sent to the load balancer the moment the data is redistributed. So the load balancer gets that information, and whenever a request comes, all right, a database update has to be happen. The load balancer will maintain all this information. It will look where in which node the corresponding request has to be sent, and then that request will be sent from there. Okay, there is a mechanism in place to understand how the data is distributed. All right, so you can it's like the metadata of the data. So that information will be maintained and it will be sent to the load balancer. All right, let's move on to the next slide now. So, so among the three properties that we have seen from the CAP theorem, all right. So these are all the databases and where they would fit in. So if you see the RDBMS, so it comes, so it mainly considers the consistency and availability part, all right. And similarly, these are some of the NoSQL databases, MongoDB, HPs, and Redis. So they consider consistency and partition tolerance. So before coming up for any specific application, before you want to start using a database, so you might want to check this particular picture. All right. So which database supports what? So what parameters are being considered for that database? All right. So as the CAP theorem says, two must be satisfied. So this is how these properties are being considered by these databases. All right. So as I have mentioned, NoSQL databases, they do not satisfy the ACID properties, but it is the base properties that they satisfy, which means the base refers to basically available. So the system does guarantee the availability. It will be up and running all the time. Okay. And the next one is soft state. Soft state means this is with respect to the consistency. All right. So what happens is, you might have heard this feature of journaling, just to make you understand about it. So journaling, what it does is, when you try to do some inserts, okay, there is a journal file maintained in the system that maintains a track of all the changes that you have done. And first of all, it will write those changes to the journal file, and then at a later point of time, it updates on your disk. All right. So this is what is eventual consistency is. So the soft state means, so even though it may not update it the very next moment, but these databases, they ensure that the database is eventually consistent. All right. So that's how they maintain that. So that is the third point. So eventual consistency, which means the database will be consistent over a period of time. Okay. So most of the NoSQL databases, they satisfy the base principles. So as I've said, there are around 150 NoSQL databases in the market. So if we categorize all these types of databases, all right, so these are like 4 basic types of databases. One is document database. That means the data is stored in the form of documents, all right. And then we have key value stores. So it basically supports only, so basically if you look at the data, right, it's all about the key and the corresponding values that is present, all right. So if you take, if you have heard about memcached, so that's an in-memory database, all right. So it is basically a very simple key value store, all right. And then we have graph databases, which are mainly used when your data is mostly linked or related, all right. So this is, you might have seen this application in LinkedIn, all right. So next to your profile, it shows the link, like how you are linked to different people in your network. So that is where, you know, a graph database. So those are the use cases where graph stores are used, okay. And then the fourth one is the column store. So where data is stored in the form of columns, okay. So Cassandra basically is a column store, and the MongoDB is a document store, okay. All right, so here is another list of all the other databases, the key value stores, and then we have column-based, document-based, you know, couch-based. MongoDB are the document-oriented databases, and then with graph stores we have similar flavors of NoSQL like Neo4j, Oracle NoSQL, etc. All right, now selecting a NoSQL database. So now that see, initially the categorization was between RDBMS and NoSQL. So we understood like what RDBMS is good at and what we can achieve using NoSQL databases, right? Now again, we have seen different categories under NoSQL database. So we have document-oriented databases, all right, and we have key value pairs. So imagine you have a simple application where, you know, the data model is like generating only key value pairs. So you might want to restrict to a specific type of NoSQL database again, right? So again, under NoSQL, you may want to go for a key value store. So maybe if you have a requirement, like I don't want to persist the data on the disk, but I just want to, you know, whatever the data gets generated, I want to do some processing of the data and again, you know, display that data from the application. So and caching layer would be sufficient for me. So that is where you might want to opt for a key value store, because like memcached, okay, so it only has a caching layer. The data is not stored on the disk, all right, like that. So first of all, we need to come up with the list of things that are important from an application perspective, and having, you know, the pros and cons of all these different NoSQL databases. So the first categorization, you know, the first thing we have to think about is about whether it should be a RDBMS or a NoSQL database. And then coming to NoSQL, again, based on the different categories that we have and based on the application requirement, we may further decide which NoSQL flavor would be most suitable for your application. Okay, so here, as you have asked in some of the queries we have, so this is the general architecture. You can just refer to both these slides. Okay, so as I mentioned before, the NoSQL databases, you may not find this caching layer over there. So here it's a different layer, but with NoSQL they have this inherent, you know, property of supporting that, so replacing that caching layer. So this would be a simple example, you know. This is the application, the database layer, and then your caching layer has been replaced. Alright, let's go through these individual databases quickly. So starting with Cassandra. Cassandra again is an open source distributed database system. Alright, So it is if you look at the advantages of Cassandra, it is high performance. It is mainly used for distributed database data storage. All right. So it has it also supports high availability with no single point of failure. So these are all some of the advantages. You don't need a caching layer. These databases, they also support inbuilt. They also have inbuilt data compression utilities. Okay, and then they are also cloud compatible. Nowadays, every application is every organization is opting for cloud. So all these technologies, they should be supporting the cloud. So this Cassandra is one among them. Okay. Again, so looking into each of these features, okay, so it has its own query language like SQL. It has SQL, Cassandra query language. It also has a MapReduce support. All right. So, and then it supports tolerance, fault tolerant, consistency, and as I've mentioned before regarding the concept of replication. Okay. So it supports replication. It has the inbuilt support for multi-data center replication. We can have n number of instances among which data is distributed, and again each instance will have a number of replicas, all right, configured, so that in case of a disaster recovery, the replica will turn to a primary and it will start serving the request, serving the loads. Again, so what are all the use cases where Cassandra is a good fit? So where you have billions of records and columns, like the big data, and then there is the velocity is high, I mean, the pace at which the read and write operations are happening. If they are very high, then so Cassandra can be a good fit for those applications, and also you have wide column requirements, and then there is a change of schema every time, or once in a while you might want to change your schema. All right. So that is another requirement, and the next one is no multiple secondary indexes. So as I mentioned before, to an extent, these databases, they do support indexes, but if you require multiple secondary indexes and all, this may not be the right fit. All right, and then if you have low latency, then also you might want to opt for Cassandra. Okay. So don't use Cassandra if your application has or require secondary indexes. Number two, relational data. Cassandra mainly supports non-relational data, semi-structured, unstructured data. It is not for relational data. Okay. And then if your application is expecting transactions, that means you might want to do some operation, and if you feel that it is not ready, you might want to roll back. So these are not the kind of databases that support the transaction model. Okay, and then if you're expecting strict security, and if you're expecting authorization at a data level, so Cassandra may not be a right fit for you. Okay. Other than that, the other two options are searching the column data and also having dynamic queries on the columns. All right. So if you have these specific requirements, then Cassandra may not be the right fit for you. Okay. So these are some of the use cases for Cassandra. Some of the companies that are making use of it, the columnar database, in order to store the data. So you can see here some of their use cases as well. So they have migrated from RDBMS to Cassandra. So it's all about, as you can see, right? The 1.5 analysis of 1.5 billion calls and storing 80 million records. All right. So it only deals with huge amount of data, and also this data will be distributed across. So its performance is so if you're looking for a single instance, all right, then Cassandra may not you may not feel the performance of it. Only when you have a cluster, multiple instances, then only you can see the performance, how you can achieve the end goals using Cassandra. All right, so the next one is MongoDB. So MongoDB is a document-oriented database, which means data is stored in the form of documents inside MongoDB. All right. So, so what is the format of the documents? So data is stored in the form of JSON documents. All right. So JavaScript object notation. Internally, the data is stored in the form of BSON. All right, which is a binary JSON, which is what do you say, an advanced level, next level of JSON. All right. So any kind of data. So there are a lot of you can write your application in any language. MongoDB basically supports a lot of languages, Java, C, C++, .NET, like that. All right, and these vendors, they make all kinds of drivers available for the users. So irrespective of the development platform that you have, you can start making use of MongoDB. All right, you can download the drivers and integrate your application with the Mongo database. Okay, so coming to the features of MongoDB, so it is document oriented. You can run ad hoc queries, and then indexing is supported. So even the MongoDB documents do have an index field, a primary index, and then it supports replication. So replication and sharding are the inbuilt features of MongoDB. Okay, and then we have load balancing. Usually with RDBMS, a separate load balancer will be used that distributes the load. Whereas with MongoDB, there is an inbuilt functionality which acts as a load balancer. I will show you what the load balancer is, how it performs. Okay, and then we have aggregation function, which means, so MongoDB also has a query language. So basically, it is in the JSON format. Okay, so but it is rich with the aggregation framework that it supports. That means most of the functions that you see in RDBMS, like group by, order by, sorting, right? All these functions are, they are also available with the aggregation framework of MongoDB. It supports all those functions. So we'll see how those functions are. And then we also have a server-side JavaScript execution and capped collections. So in the MongoDB world, the tables are called as collections. All right. So a collection, again, here this is one specific type of collection called as capped collection. So which is, you can imagine that to a circular buffer. All right. So instead of a normal table that you imagine, you can imagine a circular table. Okay, which is of a specific fixed size and nature. So the data can be inserted till the extent, till the the size that you have allocated for the table. After that, the data will be overwritten. All right. So it's almost like a circular buffer which is there where you are inserting the data. So that's a different category of collection. We'll see that collection as well, like how it look like. So next one is, so here we have a quick example to explain the data model of MongoDB. All right. So imagine that you wanted to have a blog. All right. You wanted to post blog. So these are all some of the general information with respect to the blog. Like you wanted to have a unique title, description, URL. All right. And you wanted to have a lot of tags, and then some specific button in order to like your tag, and the comments that the user posts. All right. So all this information related to the blog. Now let us see how this data can be placed inside an RDBMS as well as inside a MongoDB. All right. So I'm sure you might have this in your mind that in an RDBMS there will be multiple tables, at least with the kind of data that we are seeing, at least 3 different tables. All right. So one table, okay, I'm going to put comment ID, post ID, all this information, which will be linked to another table called posts, and the third one is about tags. So you're going to store this information in 3 tables, and whenever you query for some information, you may want to join these tables and display that to the end user, right? So this is the generic RDBMS way of storing the data. Now, if you go to MongoDB, all right, So you can see this is called as one document. So this is the which is in a JSON format. So you have key value pairs. Okay, so this is key, the corresponding value, and it also supports arrays. That means inside the value, again you can have nested key value pairs. All right, that is the basic JSON format, JavaScript format. So the information which is stored in 3 different tables. So here we are storing all that information in a single document. So if you want to query something, you just have to request this document only. So from this document, you pull the fields, whatever you wanted to display, and display that to the end user. So here no joins are involved, right? So like that, imagine huge volumes of data with multiple tables. All right, when you perform a join operation, all right, it's very expensive. Whereas here, all the information, all the related information is stored in a single document, and that information you can filter it and display it as per your requirement. So as a developer, so you define all the information for a document, and when retrieving it, you also define the fields. So everything lies in the hands of the developer. So it will be convenient to develop the application that way. So that is how these databases have been designed. So these are the way to use MongoDB. So it is mainly a replacement for web applications, content management, and high-speed logging, real-time analytics, because it supports a very good framework, right? And then we have caching layer. MongoDB supports memory map files. All right, so that's how the operations could be very fast. All right. And it also, apart from the replica concept, it also supports high scalability. We have a concept called sharding, where the data will be split across the instances. So I'll explain more on that. So that is how it supports high scalability as well. All right, and then also it is a right fit for SaaS and gaming related applications. So what it is, when not to use MongoDB, again the same like other NoSQL databases. For highly transactional applications, MongoDB is not a right fit, and then applications where you have foreign key constraints, MongoDB may not be a right fit for those use cases as well. Okay, so these are some of the users of MongoDB. All right, let me go through a few questions, and then I'll show you a demo of these databases, how to install, how to run a server and a client instance. All right. Okay, so all right, this question which I have seen, the last one, I could only see one question. This is regarding, this is from Anshul. How will update happen on MongoDB? Won't it be costly as compared to RDBMS? Well, for this question, I was just saying that since in RDBMS, we have multiple tables and joins are involved. So with respect to NoSQL databases like MongoDB, right? So there are no joins involved, as you have seen the simple example which I've given. So all your inserts would be happening on that particular document only. So it is at a document level. You will not be combining. There is no concept of combining the collections, but it supports the concept of having nested fields. You may want to have collection inside a collection. So that is what it supports. So by the end of the day, you'll be querying only one particular collection for your data. All right. So there is another question: does MongoDB support append or update operations? Yes, it does support all these operations. As I've said, it has a very good framework, all right, aggregation framework. It supports all these operations. We can also do group by, join by, all the operations. And we have another question from Shashank. Can we use indexes in MongoDB? Yes, we can use indexes in MongoDB. It is supported. All right, so let me give you a quick demo, and then maybe we'll go through the question answer session again. All right, so I'm using CentOS instance. All right, I'm showing a demo on my CentOS instance. So this is a CentOS 6 instance. All right. So what I did is I have quickly downloaded the MongoDB package. I hope you have gone to the MongoDB site. Or all right. Let me show you the package. So this is the latest version available. MongoDB 3 is the latest version. Okay. So I have taken this tzz format tar.gunzip and I have extracted this particular package to this folder. All right. Now here inside this package, so even if you take a Windows version or a Linux version, all right, once you extract the package, you would find a folder inside called as bin. Okay, this contains all the binaries related to MongoDB. Okay, as you can see, MongoD in this list, MongoD is the binary or the daemon behind the Mongo database. All right, and then we have something called Mongo, which is a client. Okay, like you have SQLD, MySQLD, and MySQL. Similarly, we have MongoD and Mongo. Okay, and then some of the other binaries that are available are Mongo import and export. If you want to import and export the data from and to MongoDB, it supports different types of file formats like JSON, CSV, like that. So those are the tools that are useful in order to do those operations. And then we have Mongo dump and Mongo restore operations. So basically, if you want to dump an entire database or you wanted to maintain those dumps periodically in case of any failure, you wanted to restore it to another system and make it up and running. So for those operations, we have Mongo dump and restore. And then some of the other binaries here are useful in order to monitor your MongoDB. So Mongo stat and also Mongo top, like that. Okay, so just giving you a brief of what these tools are. And if you want, before starting a MongoDB, you need to make sure that you have a data folder where the MongoDB is going to store the data. Okay, and then you would also be using a logs folder where you may want to store the logs in case if your instance doesn't start, it would dump those error messages into those logs. All right, so I'm quickly showing you how to run the MongoDB. So /MongoD, so that is the daemon that starts your server. Okay, and -- db path. So what I did is I have created a data folder in my previous directory, okay, which I'll be using in order to store the data. And then -- log path, even I created a logs, and you can give any name. All right, so mongod.log, it is gonna create it and store that information inside that log. Okay, and I'm going to run this server in the background. Now the question is, what is the port on which the service is going to run? So MongoDB by default runs on the port 27017. Okay, so the server will listen to the client requests on the port 27017. Okay, now what I'll do is I'm going to take a new file, mongo new.log. Okay, let's see what is there in that. Logs mongo new.log. Okay, so these are all the list of logs that are generated. Okay, here if you see the server instance has started in this line, it has started on the default port 27017. Okay, so here you'll get all the error messages as well. So now that your server is running, that is your MongoD instance, now you can run Mongo, that is the client. Okay, so the client will try to connect to the server at that port 27017. So now I have connected to MongoDB. Okay, so some basic commands maybe to give you some understanding. So DB, so I have connected to the test DB. So if you want to run your server on a different port, you can pass that as an argument when running your server. So along with --db path, you can say --port as that port number. Then using the client, so here I ran /mongo, whereas you will be mentioning host name colon port, okay, and then DB name and then connect. So that's how, if you are running on a different port, you'll be connecting to your server. Okay, so let me connect again. So I have connected back. So this is the database to which I'm connected. You can do show DBs to check all the databases that are present in the system, and you can do show collections. Basically, collection is called as a table in MongoDB. Okay, so here you can see that a file got generated called as system.indexes. So whenever you create something, then the corresponding indexes would get generated. Someone has asked this question, like whether it supports indexes or not. Yes, it does support. Okay, and so these are all the collections which are there. I'll show you the format of these collections. So basically, there is a format that is followed in order to query the tables or in order to insert or do update operations. Okay, so here db dot, you can see, so that is the default convention. So all operations that are performed on databases, so they'll start with db dot. Okay, so db dot, my column is col1. So I hope you might have observed that it supports tab completion feature. So col1 dot, I say insert. So again, inside insert, we need to follow the JavaScript notation, that is key value pairs. Okay, so for example, x colon 1. Okay, it's a key value pair. Enter. So it has inserted it. Similarly, comma, let's say y colon 2. Enter, inserted. Now in between these two examples, I hope you have understood that it doesn't support schemas, right? So in the first entry I made is I have updated a single document, and in the second line I have updated 2 documents, like that. So there is no specific format defined, no schema defined. Now I'm going to do z colon. This time I'm going to insert an array. Like that, you can have nested document structure. Okay, so this is how you perform the inserts. Now db dot col1 dot find off, so it will display those documents for you. Now do this dot pretty off. So you see, so it's key and a value pair that is there inside. Now if you observe in all these fields that I've inserted, so there is an additional field called underscore ID is equal to object ID some random number. So that is like your primary key. All right, so by default, whenever you insert a document, automatically this field would get created along with the other fields, and the default, by default, the indexing is enabled on that particular field. You cannot modify this field, so this gets generated by default. But if you want, it is possible to suppress the output, suppress this field from the output. All right, but you cannot avoid it. So like this, you can see, you can randomly, if now I'm in this database, if you want to create a new database, just say use fbobo, so that database get created. All right, similarly, you just have to say db dot collection dot insert. You need not have to create, but directly you can start inserting the data. So this is how data gets inserted inside a single instance. All right, so for this single instance, so this instance is running on a particular port. Now what I can do, I can parallelly run 3 more instances on 3 different ports and configure them as a replica set. All right, so there was one question like, how does the data gets identified? So basically, if imagine that there are 100 records. All right, these 100 records are split across 10 instances. So this process is called as sharding. All right, we have an auto sharding feature in MongoDB. So for example, if you add new instances, automatically this data will be distributed among all the 20 instances. All right, it's an inbuilt feature. We need not have to manually trigger anything. So whenever this auto redistribution happens, all right, I hope you have, I haven't mentioned about it. So here, along with MongoD, there is another binary called MongoS. Okay, so MongoS is called as a router. Okay, so it performs the operations of a load balancer, and it also takes care of maintaining the metadata of the system. That means now all the 20 shards that I mentioned, that means each having 10 documents each, total 100 documents. So this distribution is this is called as sharding. Now every instance is having 10 records, right? So MongoS, what it does is it will maintain that information. So it will say that, okay, instance number 1 is having records 1 to 10, instance number 2 is having records 11 to 20. So like that, every time an auto rebalance happens, this information will be sent and that information will be maintained. So along with Mongo and MongoDB, basically if you take the architecture, right? So let me show that to you. So basically it's the MongoDB that is responsible for starting your server. Okay, and with respect to MongoDB architecture, basically there are 3 different types of servers. The first one is the shard server that maintains the data. You have something called config server. Okay, so previously I have combined these 2 functionalities, like load balancer and also storing the metadata. Basically it is the config server that maintains metadata, and the shard server has the data, and MongoS, which is the router that takes care of the load balancer operation. Okay, so if you take the architecture of MongoDB, so you have an application layer, and then you have the drivers, the driver layer. Okay, let me quickly show this. So take imagine this as an application layer. Okay, and then you have your application specific drivers for Java or any one that you have chosen. Okay, and then you have a router, which is basically a MongoS. Okay, here, and then you have something called, it's the same MongoDB instance, but it will be run as config server. All right, now at the bottom you have shard servers. So as I've said, if you have 100 documents, you have split all the 100 documents across these servers. Okay, now what happens is, let's take 5. So automatically, whenever a request goes from your application layer, okay, using the driver, it will try to connect to the router. Okay, now this router, what it will do is it will try to contact the config server. So config server only has the metadata. Okay, so it will contact the config server, and it will understand that, okay, this information is present in shard 1, so the request will be routed to shard 1. Similarly, the request will be routed across all these shards. Okay, like that you can maintain multiple config servers. For production, it is mandatory to have 3, and then you can have a number of routers as well. So like this, if you want, you can keep on increasing, scale it horizontally and increase the number of instances as per your load requirement. So this is how the basic architecture lies with respect to MongoDB. So we have all these topics as a part of our syllabus. Okay, you can go through these slides, the course related information, like what are all the crude operations that are performed, how to design a schema, data modeling, how to administer. So I haven't mentioned about the security features of MongoDB, but there is a very good amount or list of security features which are there with respect to authentication, supporting Kerberos support. The data communication happens at using SSL. So that is the one. There are also some other good features which are part of the syllabus. Okay, so we covered the scalability, availability, replication, and the sharding part. Regarding the indexing, aggregation framework. All right. So all these features are covered as a part of this course. All right. So other than this, similarly, even with respect to Cassandra, so starting with the data modeling regarding the architecture, an overview, and how to configure it, how to monitor and maintain, tuning the database. All right. So all the important topics are included as a part of this course. All right. So let me quickly take up questions now. Yeah, so there is a question from Praveen. Can NoSQL ever be used for transaction purposes? The answer is no. You cannot use Cassandra or MongoDB for transaction purposes. They are not supported. All right. And then, so another question from Anshul. So say if in your example, if I get one more comment, then first I need to update that post and then update the JSON file, one more comment in array. See, basically the data is stored in the form of JSON documents. All right. So even you can, so when you do a find, all right, when you find query, that displays the output in a JSON format. So if you have a new comment, so basically in the example that I've showed you, all the related information is stored in a single document. Okay. So if you do a new comment, all the associated information along with the comment will be stored in a single document, if that is the kind of data model that you have. Okay. So another question from Anirudh, can one key has multiple values associated with it? Yes, as I have showed you this example. All right, here maybe I will quickly show that to you again. All right, so okay, so this is one example I showed you. I'll go to another database, db.call1.findout. See here, so basically key values. Okay, you can also have multiple values, so you can insert an array inside in the value field. So key and in the value, again you can have array, or you can also have nested arrays. So key in the value place, again have a key value, again in the value place you can have a key value, like that. Yeah, so there is another question from Ujja Shankar. Since the IDs are, I mean, how do we know which data to retrieve and which one to update when we don't have the primary key, the ID? See here, underscore ID is the default, field on which indexing is done. Okay. And you need not have to remember those IDs. I'm sorry, I don't think I have understood your question well. If you want, you can also enable indexing on the other fields. So what I mentioned is, so you have this underscore ID field where by default the indexing is enabled. Other than that, if you can also have multiple indexes. So another question from Isaac. I thought Cassandra and MongoDB has GUI for query, etc. Yes, there are tools available. All right. So one is RoboMongo. All right. You can use that as a front-end GUI. You can connect to Mongo database. You can perform all the operations using that GUI. Okay. And then there is another question. All right, so another question is, will we use those GUI in the training? Yes, those GUIs are also used in the training. We will be using both the CLI as well as the GUI part. So the next question we have is, will training cover both admin and development? So far you can see the topics that are being covered here. All right. So let me take MongoDB course as an example. So starting with the architecture, installation, the CRUD operation, schema designing. So schema designing is kind of comes under the development part. All right. And then we have indexing, aggregation framework. All these are there as a part of our syllabus. So we also covered the replication and sharding part. So other than that, there might also be topics on how you can integrate the database. So how to make use of the driver, how to integrate that to your application, like that. Okay, so as you can see on my screen, I'm not sure if you have followed this on how to retrieve the data. So db.collectionname.findOf, so that will print all the information that is present inside the database. Okay, you can use pretty-of to display in a user readable format, the way I have done. Similarly, you can do db.call.removeOf in order to delete the content, and db. You can simply say drop database off in order to completely drop the database. So as I have mentioned before, there are a lot of commands available. Most of the things that you perform are the corresponding functions are available here. So there is another question, like in terms of performance, which is the best, MongoDB or Cassandra? See, as I have mentioned before, right, even if you have compared this with an RDBMS, we cannot give an exact answer. It totally depends on your use case, on the kind of application that you wanted to come up with, and the kind of data model that you are looking at. So you need to, associate that along with the advantages of these features, the advantages of the features of these databases, and then you need to pick one among the two. All right, let me take up one last question. Maybe if there are any questions left, we will follow up on those questions. All right, and we'll post it in one of our blogs so that you can refer to those queries. So one last question from Vidya Shankar. Let's say I'm on Facebook and we have data stored in JSON from many users. Okay, how do I retrieve data just about my company? So here, see, you're saying that you're on Facebook, you have data stored in the JSON format. Yes, basically the driver converts it and stores the data in your database in the JSON format. And again, when it comes to the querying part, okay, so how can I retrieve this data? What if my data is split among multiple collections in MongoDB? So here, right, basically the concept comes from the developer end to the database. It's not like the database has been built, everything has been set. Now you come to the developer's position and think how to query the data. But everything lies in the hands of the developer. The developer decides how to store the data. If you're expecting that all your company related data must be part of a single database, a single connection, so you come up with a data model like that and store the data, and based on that your retrieve operations will be dependent. All right, so that is how we have to model the data, from like quite the other way around. The way you do it in RDBMS is opposite to what we do here. So everything lies in the hands of the developer. So as per the model that he has in his mind, based on that the application will be developed and the data will be queried. All right, everyone. So that's all that we have for today's session. Thank you so much for attending the session today. So once again, I would like to thank you all. I will be going through all the list of questions that you have posted. If there are any questions that are not being answered, we will definitely post these questions in our Edureka blog. All right, and this video would also be posted. You can also refer back to the video and also the course content which I have shared. So this course content is visible, will be visible to all of you. So both MongoDB as well as the Cassandra course. If you have any additional queries on any of these topics, feel free to shoot your queries to our support team. They'll be able to help you a lot. All right. So thank you so much once again. Have a good day. Bye-bye.